Hello all and welcome back. So in this video, let us now continue our discussion on BSTs, and now let's see how can we define a BST node. So let's get started. Now, before we begin on defining, let us first discuss that what is exactly the structure of my BST. BSTs, just like binary tree, are having a left child and a right child. It is some property which we are enforcing on it, but that doesn't mean the structure or the way we are printing as well is going to change for my BST, right? I'm just saying that once the structure is ready, or once you have defined a particular binary tree in the same structure, of course, with having a left and the right child, you should just follow this property, and then I will say you are a BST. Okay. So ideally, as we discussed as well, it's a special kind of binary tree only. But yes, it has some property which we have enforced on the same. So the structure is actually going to be exactly same as it was for a binary tree node. But still, to make sure that we have this overall idea and a differentiation, we will make sure that we are able to define this node with a name of class BST node. Okay, so let's go to the VS Code and just define the same. So this is the BST node and printing, everyone. Class BST node I'm defining. In this, we will have a constructor. In this constructor, self and data. Right. Now, what I have to do, self dot data is going to be equal to my data. Self dot left, none. And self dot right equals none as well. Okay, everyone. So I hope this is clear. Exactly same structure, just that we are saying it's a BST. The reason for that is because I want that, okay, if someone sees that it's a BST, he doesn't make any changes to my trees overall. Okay, great. Now let us see how the print function will work. With respect to a BST, I believe that for printing, we can use in order. Okay, so let me just explain why that can be true. So we have discussed about all these in orders and pre-order and post-order. They are all the traversal, different traversal, the way we can do on our binary trees. Now, when I'm talking about BSTs, okay, and I have defined, let us take an example only rather. So let's say we have a BST something like this. Let's say it is 3 here, here it is 4, and here it's 2. Similarly, this side we have 8 here, 6 here, and here it is 10. Now, when I will be making the overall in order of this particular tree, I will be traversing something like this. So I will first go here. In order says that first the left subtree, then me, then the right subtree, or first the left child, then please pull me in, and then the right subchild, right? So if we see this, it's going to be something like this. 2, then we can go back here. 3 will say that, okay, you are done with my left part, so now print me. And please now go to the fourth part, and 4. It will go back. Now 5 will say, okay, if you are done with my left part, please print me, and then go to the right part. Similarly, 8 before printing will say that, hey, please first print the left part, then you can come back to me, print me, and then go to the right part. So you will see that it's a sorted overall nodes, right? And that is always going to be true. The in order is going to be sorted for your BST because we are making sure that we are printing in that order. If everything on your left is smaller than you, if everything on the right is bigger than you, and you are seeing in that format only, where you are starting from left, then you, and then right, then of course it's going to be a lot, it's going to be sorted. Okay. So let me just write this quickly, the in order traversal. I think we have done this again a lot of time. So print BST, print underscore BST, root dot left, print root data, and we used to do like this, and then print BST root dot right. Okay, so this will just give me the in order traversal. I can say write it here as well, in order traversal of my BST. That said, it is not the case that pre-order and post-order will not exist. Like again, they are just coming from binary trees. So all this will also be there. Along with that, we can also print it in the structure, the way we printed for a readable. But before that, let us just try to first check this out if this is working exactly fine or not. Now for the same use case, what I have done is in the last two trees modules, we have the predefined generic trees and binary trees, right? So here I have defined some predefined binary search trees. This is a structure which we can see. So 5, 10, 15, it's a BST. 5, 10, 15, 20, 25, 30, and 35. It's a BST. And this one is also a BST, though it's quite long. So we know the drill, how we have to get this out. So we just have to copy this, okay, to get the three roots. And what we can do, I can just import, from predefined BSTs, import, create predefined BSTs manual. So this is the function, and I will be getting three roots. Now what I can do, I can just do root 2. Now you could have made a BST yourself as well. We could have taken the input, but again, that would have been a lot complex. So it's always good that we are able to take these created examples. So yes, I think we are able to see that it is sorted. Now one more way we of course used to print our trees was something like this. So I'm pasting this function, something which we have written already. This is the function, everyone. So in this format, if you remember, right, we used to print in this particular format for the left child and the right child. So let us do this. It's again pre-order, just that it is giving us some extra information as well. So if we print by this pre-order, 1 second, this, yeah. So we can see that 20 left 10 right 30, 10 left 5 right 15, and like this we have seen this overall structure a lot of time. So yeah, that is another way we can print our binary search tree as well. Now moving forward, we will actually do some questions before we jump into our BST class, because I want all of you to get comfortable in how exactly is BST helping us. Okay, so this is all the similarities which is there with respect to binary trees, but now everything which we will be doing will be different the way we used to do in a binary tree or a generic tree. Okay, so let's meet in the next video, everyone. There we are going to now do operations on binary trees, which will actually help us to understand how they are helping in optimizing our operations. Okay, so cool then, everyone. Let's meet in the next video. Thank you.